Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we are going to be talking about percentage yield and how to calculate it. So let's get started. Well, first of all, what actually is yield? Yield is a way of describing the amount of product that you can make from a certain reaction. And essentially what you're doing in this part of the course is calculating how much you can make of something based on theoretical ideas. So there's different versions of yield in this topic. So just to clarify what each of them means, we have theoretical yield, which is the maximum amount of product or the maximum mass of product that can be made in theory. We have the actual yield, which, as you can imagine, is how much you actually make when you have done the experiment. And the percentage yield is looking at a comparison between the theoretical and the actual yield as a percentage. So let's have a look at why the percentage yield is often a lot less, or even the actual yield is a lot less than the theoretical yield. So if you look here, you can see the reasons for this are quite a few. But one of them is because of the practical losses. Often when we actually do an experiment, we have human error. We also have different parts of the experiment which can lead to a reduction in the amount of product we can make. So things like filtering, a lot of the filtrate can be left in the bottle. We can also have a lot of the solid that is left in the filter funnel and the paper. Also, when pouring a liquid, you may spill some. Those are different types of physical things that can actually happen. However, also in lots of reactions, especially more complicated ones and industrial reactions, we can have something called a side reaction, which essentially is when lots of the reactants start to do their own type of reaction which you may not have anticipated instead of the one you want them to do. And this particularly happens in chemistry. And there can be tweaks that are made to prevent this from happening, but often side reactions, they kind of are inevitable. It's something that will just happen naturally. We can, however, change some of the environmental conditions like temperature, and that can sometimes help. Also adding a catalyst, that can also prevent this too. Incomplete reactions as well. If we have any limiting reagents, if we have a huge amount of mass of one reactant and not enough of the other, there's only so many activation sites that can occur. If there's an enzyme, for example, there's only so much product that can be made if the reactant is actually in a limited supply. So, by the way, if you are interested about limiting reactants, I'll leave a video that I did recently about those sorts of calculations as well. So these are the sorts of things that can actually cause the actual yield to be much less than the theoretical one. So when it comes to calculating percentage yield, there is an equation that you need to know. Of course, there's another equation that you need to do at GCSE. But one of the ways that you can actually remember this is thinking about the phrase, actually, I think, and that helps you to know which part goes in which place, if that makes sense. So, for example, actual yield is divided by theoretical yield. A lot of the time, students will not realize that is the way around it needs to go. Sometimes theoretical yield students will put at the top. Just be very careful because you will get the wrong answer if you do that. Make sure your actual yield is your numerator and your denominator is a theoretical yield. And don't forget to times by 100 to get it into a percentage as well. So here's an example. It says iron oxide reacts with sulfuric acid to make iron sulfate and water. This, by the way, is an example of a neutralization reaction. You've got iron oxide, which is a alkali or a base. You also have sulfuric acid, which of course is an acid. So an acid plus a base will make a salt and water. So the salt is iron sulfate. If you do want some help with naming salts, let me know. I have got some revision on there in my YouTube and also on my Instagram and TikTok. If you are looking for content like that, I do have that. I'll link some for you. But anyway, so those react together, they produce iron sulfate and water. In the experiment, only 1.3 grams of dry iron sulfate crystals are made. That's quite a low yield. Initially, I would say that looks quite low, but it depends. It depends what the theoretical yield is. So if the theoretical yield is 3.1 grams, calculate the percentage yield of iron sulfate. So what you want to do in every single equation calculation you need to do is write out the equation first. So the percentage yield is equal to the actual yield divided by theoretical yield times 100. So the actual yield in this case was 1.3 grams, but it was divided by a theoretical yield of 3.0. If we work this out in our calculator, we get an answer of 0.43, and times that by 100, you get 43%. So it's a pretty low yield. It's less than 50%. The student who is doing this or the scientist who is doing this would definitely need to think about the conditions of this practical. As we know, whenever you make salts, you need to use a filtering step. That is a required practical, by the way. Maybe iron oxide needs to be in excess as well. That could also be something that the student could do to improve this experiment and get a higher yield. So here's a go for yourself. Copper oxide reacts with hydrochloric acid to make copper chloride and water, another neutralization reaction. In the experiment, 33.1 grams of dry copper chloride crystals are made. If the theoretical yield is 43.5 grams, calculate the percentage yield of copper chloride. Have a go at this. I will leave the solution in the description box below, but I would love to hear from you, so do feel free to comment, show you're working out, and do not forget units as always. Thank you so much for today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to give it a like and share this with someone else you think would benefit from learning more. And also feel free to subscribe. I really am grateful for every one of you who has joined this community. If you do subscribe, you will be in for a treat, because in the future I'm looking to make some walkthrough videos of exams, looking at making exam technique videos, especially for 6-mark answers. And also, as we enter the exam season, I will be looking to share lots of revision tips for you. So if that interests you, feel free to stick around and subscribe. And in the meantime, you can check out previous videos of mine and also my social medias, where I post regularly biology, chemistry, and physics content. In the meantime, have a great day, and I'll catch you in the next one. Bye.